Hi, it's Kickstarter time again. Solace, the most efficient radiator in the world. Save over 80% on your next heating utility bill. Electric heater built on completely new, eco-friendly and graphene-based technology. Oh yeah, let's go. So this is a Swiss company. There's only 5 days left on the campaign. You better get in quick. And they've raised 457,000 Australian dollars of their $70,000 goal. So this thing's going ahead with the revolutionary, eco-friendly graphene technology. And it's the most efficient radiator in the world. So they've invented a radiator heater, I guess. Got our usual Kickstarter wankery down here, which we'll no doubt look into. It's 275 Australian dollars for the early backers. That's for the small unit. 325 Aussie bucks for the larger unit. And, well, you can go all the way with LBJ, right? What can you get? Oh, you can get a whole house pack for 1,500 Aussie bucks. You can get 6 of them. Yeah, I think you're going to need at least 6 of them. So what's a radiator heater? Well, it's a heating element that just radiates heat into the air, converts electricity into heat, and Bob's your uncle. Just like these oil heaters that you're familiar with, or they talk about water-based heaters. We don't really have water-based heaters here. I don't think it's a thing, but it's a thing in Europe, apparently. Anyway, like an oil-based heater like this, so it just radiates out into the room or space that you're trying to heat, instead of having a fan, which, well, you can get these with, they're called like space heaters, and they like actually actively use fans to push out the heat and circulate the heat around the room, and they can be more efficient in terms of heating a volume of a room, for example. But their one is just like this, except that it looks flat and you hang it on the wall and it looks all funky and modern. Let's take a look at the video. Porno music.
Take a look around you. In the age of smart
Regulator,
homes, heating technology is still lagging far behind. Radiators are clunky, ugly, and cost a lot of money to run.
Clunky?
Until now. Here at Regulator, we sold this with Solace, the most efficient radiator in the world. Here at Regulator, we've solved this with Solace, the most efficient radiator in the world.
Most efficient, right?
Environmentally friendly.
Normally 100%.
Accessible to all.
Oh, look at it. Slim and sexy.
Extremely affordable to run.
Accessible to all.
Is the very core of Solus. In fact, our lab's testing has shown that Solus will save you between 80 and 95% of the cost of your heating. In order to make this reality, we invested time and effort in perfecting our unique graphene-based heating element.
Graphene paste. Just
this innovative technology allows Solus to be used in almost any application where there is a power source, whether it be in your apartment, off-grid, or with alternative energy sources such as solar and wind. AC or DC, it doesn't matter.
We designed Solace from the ground up, not only to reduce your heating costs, but to completely replace expensive and outdated radiators.
It's important to get those stands right.
The Solace system is modular, meaning it adapts to your living circumstance and can even move home with you.
Sit on
Designed
table.
to be used freestanding, wall mounted.
Gotta admit, it looks pretty good.
Tri-layered glass build offers a sleek and reflective black finish. With Solace, we moved away from the standard metal radiator.
Tempered glass.
Use
Not a very good thermal
Not
conductor.
Only does this make our product super light and therefore portable, it also offers an
heat only comes out the edges.
Scratch-resistant finish. Solace also comes with a pre-packaged thermal regulator, which you can use to set the desired room temperature. Once the temperature is reached, the heater will automatically cycle on and off to maintain the warmth instead of running.
Thermal regulator.
This saves you money, prevents
Such
overheating
advanced
rooms,
technology. It's not like any other radiator. Other radiators don't have thermal regulators.
We wanted to make a system that lasts. Unlike traditional heating elements,
oxidization resistant heating technology. It doesn't oxidize. Okay.
Meaning that it will still be just as efficient 30 years from now as it is today. At Regulator, we have years of R&D behind Solace. We have done our prototyping and laboratory
lab
tests. We already have preliminary agreements with suppliers for every single component that makes up the complete product. Which brings us to now. we want to bring you on board for the final stages of our journey towards mass production.
Journey. It's all about the journey.
Kickstarter,
You can go on the journey with them.
Invest in our first production run, raw materials, and the warehouse space needed to make Solace a reality.
And you thought you could do that for 70 grand?
You'll save money on your heating costs and make a more sustainable future possible for all.
There's so many things wrong with this. Where do you begin? The most efficient radiator in the world. These radiators here, or any bar radiator, any resistive element radiator, is by definition 100%, already 100% efficient at converting electricity into heat. That's what they do. The Solace is exactly the same technology. It is a radiated element heater. It's a resistive element that heats up, converts electricity into heat, BTUs, and heats up your room. That's it. It is absolutely fundamentally no different to any either like a bar element radiator heater or one of these oil heaters or any other non-fan based, non-convection based radiant heater. Except it looks funky. It's wedged between two glass plates, and glass is a horrible thermal conductor. So really, it's going to be radiating around the edges of this thing. So all they've done is converted the form factor of your more traditional fin-based oil type heater like this into this wanky flat thing which you sit on your wall, and even if it came out through the glass, it heats up the back of your wall. That's terrific, isn't it? And they've got two different models here. And if you have a look at here, the cheapest one is, there it is, consumption approximately 190 watts per hour consumption, or with the included thermostat, approximately 90 watts per hour. And they go in and tell you the ratings below. So let's just round it up. This is a 200 watt capable radiant heater. There's no amount of magic woo-woo graphene paste that you put inside this thing is going to make it greater than a coefficient of performance, or COP, of 1, it's called, which you can do with air conditioners, which is they're heat pumps, which is a totally different thing. This is not a heat pump. It is a radiant element heater, and they smear some woo-woo graphene paste on it, and that's supposed to somehow magically make it more efficient? Nope. It's still a radiant heater. And in this particular case, it's got a resistive element. It's going to be 100% efficient, just like any other oil heater or space heater or anything else. Now, they have a bigger model down here, which is 300 watts per hour consumption, or with the included thermostat, it's half that. Heating area up to 20 square meters. The other one was up to 15 square meters. So yeah, not much difference. So two different sizes. So all this bullshit about efficiency is just that. It is 100% bullshit in terms of converting electricity into heat, or BTUs, or British thermal units, or heat energy that you use to heat up a room, in this particular case as a radiator. Except this one, I guess you stick it on a wall, stick it on your table, but it's fundamentally no different. It's exactly the same principle. Solace is the world's most efficient radiator, straight out of the box, built with our patent-pending nanotech coating and graphene-based heating element. Solace will save you approximately 80% off the cost of your heating, compared with conventional water-based radiators, and over 95% off the cost of your heating if you heat your home with other electric radiators. Built to simply plug and play, the Solace can be integrated into any home in the matter of seconds. Yeah, so can any other radiant heater. You just plug it in. Whoop-de-doo! Now, I don't doubt their claim that it's going to use less energy. Of course it's going to use less energy, because it's only a 300 watt or 190 watt element. But even that is fake, which we'll have a look at later, because it actually draws more power than that. Our unique heating technology works with both traditional convection-based heating as well as infrared heating, meaning that each Solace unit can heat a 15 square meter space with up to 20 times less power usage, because it is a much lower heat radiator. That's why. Ultra lightweight tempered glass, total weight of 4.5 kilos. Yeah, look, I got to admit, it looks pretty sexy. the feat they spent so much engineering effort, or, you know, put it on the wall and the stuff like that. But really, like, putting it on the wall, considering that it looks like it just radiates out both sides through tempered glass, which is a horrible thermal conductor. So you wouldn't stick it like on the wall, really, from an efficiency point of view. It's just silly. And it comes with this wanky little portable thermal regulator thing, which I presume is like a Wi-Fi wireless type thing. Eco-friendly and 100% recyclable. Not only is it ultra efficient, it's also fully rechargeable. Once again, ultra efficient. Like, they talk about efficiency like it's somehow magically woo-woo different from a radiated heater. It is not. It is just 100% efficient at converting electricity into heat, just like any other radiator. You can only talk about efficiency in terms of BTUs and volume movement inside a room and stuff like that. But as far as comparing it to a regular radiator, it's exactly the same. It's just a radiant heater. Graphene doesn't make it any different. Yeah, sure, graphene has superb thermal conductivity, but that only conducts it out. It doesn't magically generate more heat. It's not a heat pump. It doesn't have a coefficient of performance greater than 1. Oh, it's got to be legit. It's seen in Forbes, Uncrate. What? Who are these? Their production process has started. Yeah, look, I don't doubt that they're going to deliver on this thing, right? They've put a lot of effort into it. Their team is, for the entrepreneurs to rocket science. They have rocket scientists on their team. Fantastic. Assembly line in Latvia. Cool. Hi to all my Latvian viewers. Why is that 80% figure common? You know, batterizer, 800%, 8 times, all that sort of, I don't know. It's good round number. Any campaign promising to save, X amount, or it's X amount more efficient, you just know it's 100% bullshit. Unlike conventional electric convection heaters, Solace combines both convection and infrared heating. What? To improve the efficiency? What? It's a radiant heater. Just like this is a radiant heater. There's no fan in this thing. There's no, why you would even compare it to a convection heater, which has a fan which actively moves things. We realize that in order to show exactly how Solace achieves its ultra high efficiency, 100%, just like a radiant heater, we needed to dig a little deeper into the technology behind the product and show how this differs from traditional heating sources and backing up some of our claims. Efficiency of heating is a multifaceted subject. It is, and whilst many electric heaters are very efficient, nearing 100%, actually all of them are by definition, at producing heat from electricity when brand new, Solace is both highly efficient in creating heat, exactly the same, 100%, maintaining efficiency through its lifetime, exactly as the others do, and also crucially at delivering heat in an efficient way to where it's needed. How? It's not a convection, it's a radiant heater. How is magically making it a flat panel with a ridiculously bad thermal performance glass on either side? Granted, you can get some glasses which are a lot better, but they don't mention that. They just mention tempered glass, that's it. And magic woo-woo graphene paste inside it. How does that magically at delivering the heat in an efficient way? How is that different to any other sort of radiant fin-based heater? Why? Because it's a large flat panel like this, and you stick it on the wall where it's going to warm up your wall pretty well. At delivering the heat in an efficient way to where it's needed, ensuring you get maximum comfort in the shortest amount of time. The shortest amount of time. So you're saying that with either a 300 watt or a 200 watt, by your own numbers, a radiant heater is going to heat in the shortest amount of time? It's going to heat a room in the shortest amount of time? What? To do this, it has to have a coefficient of performance greater than 1. This is a resistive element heater, just like anything else. It's got 100% efficiency. I mean, this is not rocket science. Watts, kilowatts converts directly into BTUs per hour. Let's have a look. So at 300 watts, say, for their large panel, 0.3 kilowatts is just over 1,000 BTUs an hour. That's the amount of heat generated. Now, if we have a look at 1,500 watts, 1.5 kilowatts, it's over 5,000 BTUs an hour. That's the amount of heat that's going into the room that has to be used to heat up this volume. And there's no other magic way around it. Sure, if there's you use like a forced convection systems, and it depends on the room and the losses and all sorts of things, but basically heat delivered into room. It's 300 watts versus 1,500 watts. Like, just me sitting here getting all excited, I'm like dissipating like 200 watts. If I was standing in that room, I'm equivalent to, you can hire me to stand in your room and rant, and I'll dissipate a couple of 100 watts. You've got to keep feeding me to energy input. You don't get it for free, but this is ridiculous. Like a 200 or 300 watt radiated heater, it might be okay if you're, sitting a couple of feet away from it, and oh yeah, look, it's warm, oh, isn't that toasty? But it's not going to heat the volume of your room. You have to have a very highly insulated room, and you've got to leave it on for a long amount of time to raise a volume of air a certain temperature. It's basic thermal physics. And it's certainly not going to do it in the shortest amount of time. You just physically can't, unless you're defying the laws of physics, Captain. Unlike conventional electric convection heaters, Solace combines both convection and infrared heating to improve the efficiency of heat delivery. How does this magically differ from any other radiant heater? Any other radiant heater is the heat's going to convect around the room, it's going to radiate out. It's exactly the same thing. What? They're making it out as if it's something magically different. Infrared heating warms the objects in the room directly, blah, blah, blah. Air stores and delivers heat fairly poorly, and the heat from convection radiators, once in the air, rises to the top of the room, not exactly where you want it. How does the Solace differ? It radiates heat, the heat rises, convects around the room. It's no different. It's exactly the same. And the heat escapes out of the room in the gaps in windows and doors. Yes, it does. This is an incredibly inefficient method of heat delivery and requires a lot of heat to warm a space. Well, how does your magic woo-woo radiant heater differ from any other radiant heater? They're just telling you all this just to bamboozle you into thinking that this is somehow magically different. It's not. Infrared heating instead warms the walls, furniture, and even the people in the room gently, which then slowly releases the heat directly into the room, offering a complete ambient 360-degree heating system. Bullshit. It's exactly the same as any other radiant heater. It radiates the heat out, and depending on where you put it, depending on other objects in the room and other losses and all sorts of where your losses are in the room, it's a complex thing. This isn't going to magically be any different from any other radiant heater. It's just bullshit waffle. Heat cycling. Our unique heating element technology harnesses an amazing quality to be able to heat up extremely fast due to its incredible conductive ability. In fact, it can heat up to 100 C in just a couple of minutes, meaning almost as soon as you turn Solace on, you will feel the warming effect. Whoop-de-doo! To heat a room, which is a volume of air, assuming that there's no losses, requires X amount of BTUs. And we'll look at an online BTU calculator soon. It's basic stuff. There's nothing new here. And they're just bamboozling you again. It heats up to 100 C and then cools back to 48 C. Why 48? As it releases the heat into the environment. Once cooled, the temperature shoots back up to 100 C. This cycle is in contrast to normal convection heaters, which require constant power. And as we'll see in the one of the updates, or one of the comments, they say it's like they pulse it 1.5 seconds on, 1.5 seconds off. Like, how is that magically going to do anything? Oxidization. As we discussed in our first update, conventional electric heaters use metallic heating elements. Over time, these heating elements begin to suffer from oxidization, which reduces their efficiency over time. Now, I'm no genius, but let's say your radiant heater uses 1,000 watts and it oxidizes on the surface of your element or whatever. How does it become less efficient? It's still consuming 1,000 watts. It's converting 1,000 watts into heat. That heat radiates out into the room. The oxidization doesn't do anything. Oh, but it gets better. When you heat a metallic heating element, you will see the element changes color. This change in color is the effect of oxidization. This creates a galvanic effect between the oxide and the heating element. This galvanic effect creates magnetic fields of various frequencies, and the wire becomes less and less effective with each use, and as it creates magnetic fields instead of heat. What? I don't even want to try and counter that. So the effectiveness of a metallic heating element becomes less and less effective until it burns out, which you can see in any other electric radiator with metallic heating element. The effects of these magnetic fields can be witnessed on a normal heater, where after turning it on, it will attract dust and small particles to it and will burn them. Normal heaters emit foul smells. Our heater doesn't attract such particles and hence doesn't emit foul smells, which is again due to the absence of a magnetic field. What drugs are they on? Seriously. We use a modified pulse current to supply our heaters. As I said, I believe it's, as they say, 1.5 seconds on, 1.5 seconds off, apparently. This works by pulsing, meaning that it isn't a constant supply. Utilizing a pulsing supply, we can reduce the amount of power being drained by the heater. Most electrical devices require micro components to convert this pulse current into a usable form. Our unique heating element doesn't need this conversion step, again allowing us to use less power to achieve a similar result. So how are they doing that? They're saying they don't need any micro components? They don't have any circuitry that does this? What are they heating using maybe a bimetallic, a thermal regulator to cut it off and on? In that case, it wouldn't be magically 1.5 seconds on, 1.5 seconds off. But anyway, okay, so they're pulsing it. That means you're delivering less heat. You're delivering less BTUs. Like, it's a simple conversion. It's not hard. Heating a room requires BTUs. If you turn your element off for half the time, you're not producing any energy during that time. You're not producing any heat. Yeah, it still radiates out heat. And, but you can't defy the laws of physics, Captain. The resistance of the heater is made with the maximum efficiency in mind. Once again, it's 100% efficient like any other radiant heater. And it doesn't matter what losses that you have in there, it converts everything into heat. Additionally, normal conductors' heating elements have different resistant values in cold and hot state. The resistance of our heater has the same resistivity in both cold and hot state. Who cares? It's the amount of energy you're producing, the amount of heat, the amount of BTUs your element is producing. As a result, our heater doesn't give fluctuations in the grid during its use. It doesn't give fluctuations? But you admit it turns it off and on, it pulses it. What? The electric resistance in our heater is adapted to the electric current from which it has to work. We have precisely measured the effective regime of Solace. The tests were conducted at the Royal Technical University in Sweden. Oh, it's got to be legit. Safety update. Oh yeah, you meet various standards. Whoop-de-doo. Help spread the word. I am. You're welcome. Referral program? Wow, I could be getting money for this. And stretch goals. Wow, we'll paint it white or something. We'll personally engrave them. Woohoo! And here's the technical specs. There it is, rated input 200 watts. That's for their small one. So of course it's going to use like 80% less power or whatever because it's 200 watts compared to like 1500 watts for a standard thing. But this puts out a lot more BTUs than this in proportional amount based on the amount of power that you're drawing, because they're both 100% efficient radiators. Again, how is this a thing? You've got the glass on the side, which is a piss poor radiator, and then you've got the little edge or whatever. It's a thin 200 watt radiant element. And as I said, it doesn't matter what woo-woo graphene paste you put in there, it doesn't magically produce more heat. So they reckon it can, heat like 15 to 20 square meters, depending on which model you choose. Would come in different colors. How many watts per hour does Solace consume? One Solace unit consumes approximately 90 watts per hour if used with the included thermoregulator. If used without the thermoregulator, each unit consumes practically 190. That's the smaller one, as I said, and it's rated for 200 watts. So right there, is it not 100% efficient? And you can mount it horizontally or vertically. Cool. Now, if you read the comments here, there's actually like a lot of skeptical people, as they should be, and you can read it for yourself. I'll link the project in down below. And their responses are just, once again, very vague and things like that. And Jonathan here really nails it. Watts are literally units of heat. Yes, you can actually convert kilowatt hours into BTUs, which BTUs is just a thing in the air conditioning / heating business, British thermal units, but it's exactly the same thing. It's just a direct conversion. The more watts, the more heat. There's no way around that. There are different styles of heaters for different applications, i.e. infrared makes you feel warmer due to heating your skin directly rather than the air, and oil radiators heat the air so they take a bit longer and are designed for longer term use. Let's put this another way. Would you heat your room with a 200 watt light bulb? I don't think so. It wouldn't be very warm. That's the same amount of heat you're going to get out of this heater. Nailed it. Unless they start claiming that they've got a coefficient of performance greater than 1, then that's exactly true. You cannot get around that. It's consuming 200 watts, but it's actually more, as we'll take a look at. Please explain why this is better than the $20 space heater I can purchase at one of the major big box stores. The space heaters are the ones with a resistive element heater plus a fan that just circulates the air around your room. And you're spot on, Jonathan. You can't use more than 1500 watts on a 15 amp circuit. That's equivalent to 5100 BTUs. You mentioned that you use 300 watts, which makes this use 80% less electricity, but in doing so, it also produces 80% less heat. Ta-da! You would need 5 of these heaters in order to provide the same heating capability the standard $20 space heater provides. Since this unit costs $350 per unit, it's actually like double that. This is just the Kickstarter. The retail price is going to be a lot higher. Any and all electric heaters, by definition, are 100% efficient. I mean, look, this is why everyone in the comments is saying this. It's obvious to even non-engineers know this. And let's look at their response to Jonathan here. Traditional heating systems have numerous drawbacks. Once again, how is this different to a traditional heating system? It's not. It's a radiant heater. You will notice all the heaters that you review on your video use the same technology. Such disadvantages are compensated by the properties of graphene, which we use in So a 100% efficient radiant heater has disadvantages that are compensated by the properties of graphene. As I said, graphene is an excellent conductor of heat. It really is. It's brilliant, but that doesn't magically produce more heat. If you're consuming 200 watts from your mains, then you're producing 200 watts of heat. The graphene is not a heat pump. It doesn't produce more heat. The efficiency of our heaters does not break any laws of physics. I know, because it's 100%, exactly like all the others. Having said that, there are numerous studies that show graphene defies the laws of thermal conductivity. We are not the only company that is working in this direction. For instance, there is a company called Cambridge Nanosystems who conduct detailed analysis, unique properties of graphene. These companies like to specialize in manufacturing graphene on an industrial scale, blah, blah, blah. We have managed to streamline the extraction process, make the production process cheaper. We can say that it's definitely revolutionary in the field of heating. Please explain how it magically produces more heat, this graphene, this woo-woo graphene paste. At the current stage, many properties of graphene are not yet clear as they are still being heavily researched. However, for your information, we are presenting this scientific article, blah, blah, blah. Well, let's have a look at an article, shall we? This is gov.uk. This is the official UK government. Freeze put on scam heating system company. I want to make it clear, this is a totally different company, unrelated to Solace. This is a Manchester-based Zephyro Trade Limited, which misrepresented graphene heating systems to the public, was wound up by the High Court. Zepho Trade Limited sold its products on the basis of misrepresentations made in promotional material, and its investigation by the Insolvency Service found the company misled the public and failed to install systems safely. Potential customers were given comparisons between their current heating systems and the potential savings, suggesting that the Zepho graphene-coated radiators could reduce the cost heating of a house by 75%. Does that sound familiar? 80%? And save 2 tons of carbon system per year. The company falsely stated that these claims have been verified by independent tests, but in fact, the cost of operating the Zepho system was more than double and produced almost twice the amount over a 24-hour period. And apparently, that's what the Zepho system looks like. So once again, it's a big panel radiant graphene heater, just like Solace, and this company was busted by the UK government for misleading the amount of energy you'll save. Oh gee, I wonder how Solace magically do any better. And there's more companies producing this. Look, graphene heating systems. Why graphene? 21st century magic technology, blah, blah, because it's more thermally conductive. People are duped into thinking it's somehow magically going to be different in a panel radiator heater. It's bullshit. And once again, Jonathan nails it. I do understand that graphene is a very conductive material, however, it isn't capable of generating heat, only conducting heat that's already there. This means it cannot be more efficient than the heaters linked in the video. It may be better at one particular application, such as IR heaters are better at providing warmth to people, while oil heaters are better at long-term heating, but it's not better at producing heat. He's 100% correct. And the reply is, in fact, we have found that raising the temperature of our heating elements is most effective through supply of non-constant pulsed electric current. It works in the following way. The heating element is supplied with 1.5 seconds of electric current and is then cut off from the supply for another 1.5 seconds. This process is repeated until the heater reaches its maximum temperature. We observed that during the off cycle, 1.5 seconds when the current is off, the heating element continues to generate heat due to the self-cooling properties of graphene, which results in a difference of potentials. They're just spinning bullshit. It's not, the graphene is not producing heat. It's just, the graphene is not producing heat with no power input. That's just bullshit. And it just goes on and on and on. Everyone's skeptical and they just try and pull out all this bullshit. At least they're answering questions, even if their answers are non-answers or just based on complete waffle or completely wrong aspects of engineering and physics. It's ridiculous. And in their update here, I won't spend long on it, they got a whole video and they claim they hired a 15 square meter room, which is bang on for what they claim for their marketing. And they showed that even under worst case conditions, the Solace, the larger panel, the M105 panel or whatever, basically used 10 kilowatts over 24 hours compared to 31 kilowatts for the 2 kilowatt oil heater. And look, you go watch it. Go watch it yourself. They've got this room here, and after 24 hours, is that good at doing 1.5 seconds on or off? Look, see where it is? Compared, it's on the wall right near those near those thermostats there. Anyway, whereas the oil heater's there. It's in the middle of the room, right? It's just, anyway, blah blah blah. They make these comparisons that it's better. And once again, everyone's questioning this as well. And it's definitely not a controlled test at all. And it was different temperatures outside. But anyway, they're making some claims. And I'm not very good at the mathematicals, but let's take the figure there of 10.6 kilowatts and divide that by 24 hours. 440 watts it's consuming. Average over 24 hours. What happened to the 300 watt rating of this panel? Oops. Let alone the 150 watts. You remember Over here, they make the very specific claim right here on the thing you're buying, 300 watts per hour. Their own test showed it consumed 440 watts per hour, or 150 watts with the thermostat. They were using their thermostat. If you watch the video, it's plugged in. It's supposed to be use 150 watts. It's actually in their own test. It's showing it's using and it's taking 440 watts. Anyway, there's so many different issues with this sort of testing. I won't go into all the details, but hopefully, look, you can see the resistive. Are they like graphene elements? And what's the paste? Is that like a magic graphene paste kind of stuff? Like what the hell? Like, it's not going to magically make it better. They're resistive elements spread over presumably they just say tempered glass, which is a horrible conductor of heat. So they've got this magic graphene, which is, okay, graphene is a brilliant conductor of heat. It's practically magical. But, and then they put, glass over it. Unbelievable. So they've just made a panel radiator exactly like any other, but they smear some graphene woo-woo paste in it and whack it up on Kickstarter, and they get like $500,000, and it's unbelievable. It's no more efficient than a regular unit. Now, it's actually quite a complicated thing to try and calculate how to raise the temperature of a room with either a radiant heater or a convection, for like a forced convection heater or anything like that. But there's industry standard calculators for these things. There's many online and stuff like that. So if we go for the exact same room that they had, 5 meters by 3 meters, i.e. 15 square meter room, 2.5 meter ceiling height, I'm going to say the insulation is normal. It looked okay. They said it was quite poor, but anyway. And let's say we want a desired temperature increase of 10 degrees Celsius. You calculate that, and you will need 4,000 BTUs an hour, or 1,200 watts. Just to raise the volume of air in that room, you need like 1,300 watts, and this thing is supposed to magically do it with either 200 or 300 watts, or 440 as we saw on the calculator. It just can't do it. This is not a heat pump. It's not magic. It's the same efficiency as any other radiant heater. The graphene does absolutely nothing. And even if we get poor like that, you're talking about 2,600 watts to raise that room by 10 degrees. And and once again, if you get like a convection based one of these like space heaters. So you can buy one of these little space heaters. Here's a little tiny, it's just a personal heater. It also is 250 watt energy efficient solution for what is it? Yeah, $11, $14 or something, crazy. It's the same amount. It's going to produce the same amount of heat as this 10 times more expensive, 20, 30 times, 40 times more expensive magical woo-woo Solace unit, because the retail price on this is going to be, it's like 40% off the price. So, it's going to be like 500 Australian dollars or something, and this produces the same amount of heat. So there's just like tons of these space heaters, and they cost very little, and they're going to be, if anything, more efficient at heating a space than, because they can use fan-forced convection to heat up the room. This thing at like 200 or 300 watts and pulsed, and it's a big flat thing wedged between glass panels. I don't have to do any more on this. Sorry, I've already spent way too long on this. So don't believe this bullshit that it's going to save 80% on your next heating utility bill, because you'll have to leave this thing on forever, for much longer than you would for one of these things to heat up the equivalent space. You simply cannot get around the required energy, BTUs, to heat up a volume of space. And as I said, it's quite complex depending on if you've got humans in there. Us humans emit, a couple of hundred watts or whatever. And then you've got furniture, you'll have dead spots in the room, you'll have leakage points and all sorts of, stuff. But sticking one little pissant little, radiant panel on your wall or whatever, that's like that consumes 200 watts, and this is supposed to be some magically revolutionary woo-woo bullshit. It's just, nah, it's done. This thing is completely busted. It's going to end up the same way as this UK government thing, this company, and they're just like... people will end up suing them, probably, because the claims are just bullshit. How is their one magically different? It ain't. So it's very likely that they really do believe that this thing is somehow revolutionary, and they just they just don't understand about heating the volume of air in a room and how that no amount of thermally conductive graphene is going to produce more heat. They're just digging their hole deeper and deeper and deeper, trying to answer all of the questions, and they go, oh, but it's going out for independent testing and stuff like that. And yeah, once we see independent testing, it's going to be no better than any other radiant heater. Now, that being said, of course, okay, this may, in some circumstances, this particular panel might actually work better for your specific circumstance, or you might feel warmer if you sit in front of it or whatever, compared to, you know, some other space heater on the other side of the room. But in terms of heating up the volume of a room, you simply cannot get around the number of BTUs required to heat a volume of space and continue to heat that volume of space based on leakage. So it's just nuts. And it's the same story with Kickstarters over and over again. They, you know, and they probably do believe in this thing, that, and they just, you know, they're so far down the rabbit hole that they have to, you know, start justifying this in every way possible. And every test they do will be slanted towards trying to give them a good result in comparison. But when you actually do proper A/B comparisons under proper control conditions, you'll find that this is a 200 watt radiator, and it's not going to produce as much heat as a 1500 watt radiator. End of story. So there might be some circumstances where, like, a lower wattage panel based radiator like this might actually be a bit more effective, not efficient, effective in terms of heating a particular small space or whatever, especially if you sit in front of it or whatever, than some larger heater, for example, one of these big 1500 watts, which you sit too close, whoa, that's too hot, so you generally back off and stuff like that. You know, there's some circumstances where it may be beneficial, but it's not magically going to heat a volume of air in a room. It's just not. It's 200 watts. And when they can't even get their own calculations right, their own tests show it consumed 440 watts when it's only a 300 watt panel, or actually 150 watts with their magical thermostat. They can't even verify their own specs. It's ridiculous. But anyway, it does look sexy, and I'm sure they'll deliver. You know, they've got enough money, maybe. I don't know. Maybe they're in the valley of death where they haven't raised quite enough money. They were never going to do this for their $70,000 goal, of course. But now they've raised almost $500,000 with 5 days to go. Is that going to be enough, or are they going to run out of money, as a lot of these Kickstarters do when they're trying to take these things into production? But I hope they deliver, and I hope the backers at least get their panel delivered, but it ain't going to be magic. Sorry, no amount of graphene woo-woo is going to fix that. Leave your comments down below of what you think of this thing. Also on the EEVblog forum, link down below. And I'll link all this stuff in as well. Catch you next time.